We're going to continue the discrete random variables. This time we don't have a table. We have to come up with our own table based off of the probabilities. And so if we're looking at our first one, it says construct a probability distribution for the data and draw a histogram. A family has 3 children. Let X represent the number of girls. So when we're coming up with our table, what we first have to do is figure out our X's. So if you have 3 kids and X being the number of girls, it's possible to have 0 girls or 1 girl out of 3 children, or 2 girls out of 3 children, or 3 girls out of 3 children. Those are our only possibilities. So a discrete random table gives us all the possibilities that we can have. Now what we have to do is we have to figure out what's the different possibilities. So this is number of girls. So if you have 0 girls, that means it's boy, boy, boy. So we're going off the probability of a half, and so that gives us 1/8. Now, another possibility, 1 girl. So that would be girl, boy, boy. That would also be 1/8. The problem is that it could also be boy, boy, or it could be boy, boy, girl. So there's 3 possibilities, and since we know the probability of each one is a half, that would be 3 out of 8. Now we're looking at 2 girls. That could be girl, girl, boy, or girl, boy, girl, or boy, girl, girl. Once again, probability of a boy is 1/2, probability of a girl, 1/2. Probability of girl is 1/2. There's 3 ways that this can happen. So that means that our answer, once again, is 3/8. Now, just as we've gone over before, 3/8 and 3/8 is 6/8. One more eighth is 7/8. This distribution has to add up to 1, so that means our last one has to be 1/8. So this right here is our table. Now what we're going to do is we're going to draw a probability histogram. Now when we're drawing a histogram, what we have is frequency along the y-axis, and along the x-axis we have our x's. 0, 1, 2, and 3. So we have our largest is 3/8, so we're going to go up to our max, which is 3/8. And so 0 would be 1/8. Then we have 3/8, and we end with 1/8. And that right there would be our distribution table. Now, if we look at letter B, this time we have a bag and it contains $1 bills, $5 bills, $10 bills, and $20 bills. Let X be the bill picked. So that means that X has to do with our money. So 1, 5, 10, or 20. Now, if we're trying to figure out the probability, what we need to know is how many bills are in the bag. So if we're looking at it, 4, 3, that's 7, 8, 9, 10. So each one, there's the probability of picking it out of 10 bills. Now for the $1, there are 4. Remember, we don't have to reduce. 5 is 3, 2, and it tells us 1. So this right here is our distribution table. Now what we're going to do is we're going to come up with our histogram. The histogram is going to be a little bit different than the last one. I don't want to draw 1s all the way to 20s, so I'm going to go by 5s. So start at 0, 5, 10, 15, 20, and 25. So the max is 4/10, so I go up to 4/10. And from 0 to 5. 0 to 5 is really 0 to 4. The next one is 5 to 9. The next bin is 10 to 14. The last one is 15 to 19. And then what we have is 20 to 20. So for the first one, it goes up to 4. Second one, it goes up to 3. The next one goes to 2. This one, we don't have one, so we're going to leave it blank. And then our last one, it is 1. Oops, that's a little high. And that right there is our histogram. Frequency, and then go. And for this last one, a number of girls. So don't be like me. Remember to label.